Okay, so if you were paying attention to the walkthrough, you already saw the answer to number 3, so we will not be doing that one. But this one is asking how much energy is needed to raise the temperature of 5 grams of gold by 25 degrees Celsius. So there's a couple things we want to remember. One, that the equation for specific heat looks like this, or it looks like this, depending on what version you're using. And there's a couple others as well. You want to be asking yourself what the question is looking for. So this one wants energy. Q is equal to Cp times M times delta T, where the Q is energy in joules, Cp is the specific heat, M is mass, and delta T is the change in temperature. So for this particular question, it's got us asking how much energy is needed to raise the temperature of 5 grams of gold by 25 degrees Celsius. So let's see what we have. Specific heat comes from this table, and it tells us that the specific heat of gold is 0.129, and the units are joules per gram degree Celsius. Our mass is 5 grams, and we're raising the temperature by 25 degrees Celsius. So when you do this, degrees Celsius cancel and grams cancel, and it leaves your answer in joules. So here's our calculator, and we'll say 0.129 joules per gram degree Celsius times 5 grams times 25 degrees Celsius. And here's our energy in joules, 16.125 joules. All right, number 2 is asking for final temperature. This is a bit tricky because we're going to be using the version of this equation, Q equals Cp times M times delta T, and we're going to rearrange it to find delta T. And it's easy enough to do. We're just going to say Q over Cp times M. So right off the bat, we are looking for delta T. That's what we're trying to find. We have a Q. That's not a Q. We have a Q of 420 joules. We have a specific heat. Well, this is water, and it's at a sample temperature of 10 degrees, which means it has to be the liquid version, and that's right here, 4.18 joules per gram degree Celsius. And finally, we have a mass of 35 grams. So let's set this up to find delta T. We know it's going to be equal to Q over Cp times M. We have a Q, 420 joules. We have a Cp, a specific heat of 4.18 joules per gram degree Celsius, and a mass of 35 grams. Now when you do this, grams cancel and joules cancel, and so let's get our answer, and I'm going to use the calculator's parenthetical function. We'll say 420 divided by 4.18 times 35, and notice that I have put the bottom in parentheses. That just makes sure it gets done first so the calculator doesn't get confused. And we get 2.87 degrees Celsius. However, stop. This is delta T. What is the final T? Okay, so delta T means change. That means that we have changed this temperature by 2.87 degrees Celsius from its original of 10 degrees Celsius. So if we have increased it from 10 by 2.87, what is our final T? Well, we had 10 degrees Celsius. We increased it by 2.87. That means our final temperature is 12.87 degrees Celsius. All right, well, I did number 3 in the walkthrough. So if you paid attention to the walkthrough, you have the answer for number 3. And if you didn't, then you don't. Let's do the last one, number 4. It's got a couple parts. It says that a 10.14 gram sample of an unknown metal is heated from 25 to 250 degrees Celsius and was found to have absorbed 1,024 joules of energy as heat. What is the specific heat? What is the identity of the unknown metal? And how much energy will the metal sample gain when it is heated from 250 to 750? So we got 3 parts here. What is the specific heat? What is specific heat? We have B. What is identity? And finally, how much energy? What is Q? And we'll get to that one in a bit. So we know that Cp is equal to Q over M times delta T. And this is how we're going to find part A. We have absorbed 1,024 joules. Our mass is 10.24, and we've gone from 25 to 250. That means our delta T is 225 degrees Celsius. So we have 1,024 joules of energy. Our mass is 10.14 grams. And we've gone from 25 to 250, so our delta T is 225. Now check out what happens. None of these units cancel, so our answer is going to be in joules per gram degree Celsius. Let's bust out our calculator and we'll say 1024 divided by, I'm going to put these in parentheses, 10.14 times 225. Here's our answer. Let's call that 0.4488. We'll round that to 0.449 joules per gram degree Celsius. All right. What's its identity? Well, that means we're going to have to look it up. Do we have a sample of a substance that has a specific heat of 0.449 joules per gram degree Celsius? And the answer is yes. So the identity of our unknown is iron. And finally, it is asking, what is the Q? The mass hasn't changed, the identity hasn't changed, but we are now going from 250 to 750. That's a change of 500 degrees Celsius. So what is the Q if we go from 250 to 750? Well, our mass hasn't changed. It's still 10.14 grams. We know our specific heat because we just found it. And our delta T, which is 500 degrees Celsius. So we're going to plug them right into our equation. So we got a specific heat, 0.449 joules per gram degree Celsius. We have a mass of 10.14 grams and a delta T of 500 degrees Celsius. Degrees Celsius cancel, grams cancel, leaves us in joules. So I'm going to bust out my calculator and we're going to say 0.449 times 10.14 times 500. Ladies and gentlemen, 2,276.4 joules. And there you go.